So, as I have said that before, we have term project example. Everything is written here. So, for grouping, you will need to read a little bit this part. So we have, it's about the same. We have 30 components, and some heavy components will be numbered using Whitson method as follows. So some of you asked me what's the difference between lumping and grouping. Mainly we have two things. We have splitting, where I split the heaviest component, and we have lumping or grouping. So lumping and grouping, we lump or group things together. It's the same. There's no difference between lumping and grouping. They are the same. Different names, but refer to the same thing. So there's no difference between lumping and grouping. And in softwares, for example, in PVTP, they mention lump. They say grouping. They don't use lump. And maybe in some corners in the software, if you try to do the same task with different options, you may find, for example, lumping. It's the same. So don't be confused. Anytime you found lumping or grouping, it refers to the same thing. When we group heavy components together, or any components, depends on your choice. So here, what we have done, we use this equation, and in this equation you will be required to define from where you will start and from where you will end. And this equation is used only for heavy components. For example, we are talking about lumping components from C7 until C30 plus. How we can lump those to several components. Here, to know from where to where you divide this, you can define your end point, your start point, and then you use this equation, and then you will have a number. So this is the number of groups that you will have. So at the end, when I did this for example, in my case, I did this from C14 to C30 plus. And I entered here the number of the carbon 1430, then I got 5. So it means I need to group the components from 14 to 30 plus to 5 groups. How I can find from where to where using this equation? When you do this and you find step 1, it means group 1 for I. Just put the equation. It's always the same. You change only I. I refers to the group. This is I. So for group 1, it will say to you, okay, your upper limit will be C17 by molecular weight. And then you can do that, then at the end you will find that you have 5 groups. C13 plus stays alone, and then you will group C14 to C17 as one component, then you one component, one, and so on. Actually, it's one pseudo component. Before we have only one pseudo component, and now we have more than one pseudo component. Yeah?
To do the grouping, we have to have 6 different groups. So we have to do the calculation again to find out.
This will help you only for heavy components, how you deal with heavy components. But I'm not sure here because we were asked to do the same. So here, how to apply this grouping. However, you will need to go with you remember the manual where you have the steps. Then you will group without doing these calculations. But in your manual, if you have a log, you have at the end you have 3 fractures for heavy component. So now the question, how you have from C7 until C33 components, how I should divide them. And this method, Whitson method, they just said if you follow this equation, it will give you representative results or something acceptable. However, you can't decide this. You can draw the so if we talk about mole, fraction and molecular weight, and here we have component. So if it's exponential like this, I can group, for example, from here to here and from here to here to two fractures. Maybe if we have something like this, then I say, okay, from here to here, I have one component, I will lump those together and the rest together. So it depends on the shape of the, when you draw the molecular weight with mole fraction, this shape and how you understand this will determine how you will lump the components together. So, and okay, this method is used to represent the C7 plus fraction of a mixture, which should contain more than C20 plus into cube pseudo-components. So this is the same. This method, it says that it can be used for if you have a C20 plus or C30 plus, then you want to represent that composition with fewer components. So you may use this method. So this is how you do that in the software. Grouping technique can be done in PVTP using this, or you go to data grouping, and then group bottom is pressed. So I can show you that in the software. So this is our last file. This is grouping bottoms. It's shown here. So if we press this, then you have two choices. Either you do grouping with automatic, where you have a method as the one I have just shown to you, where the software will calculate everything to you and make a group for you. But I don't recommend you to use that. Just try to do something that you understand. Otherwise, maybe you have wrong results and then you will not be able how to fix this. So just choose manually and press group. So here you will have all your components are added here, and then you can select it. For example, if I want to group into with C1, I can just select those and add them as one here. If I want to leave everything, I will just add a component for each row here, then I group what I want to group together. So just like this, choose into C2. This is the way if you want to group something else than those components, you add them like this. And then what I will do now, it's just I want to group all of those with one component. Something arbitrary. You will need to do this depending on your data or in your choices that you have. So now I added all these two components in one group. So now instead of having 13 components, now I have only 11. So if I press OK, they give me this window to be able to calculate the phase envelope. I see that you can see that when we lump those together, the bubble point is shifted. So now I canceled this to show you that the bubble point was matched, but after we lump, it's shifted. That means anytime you lump components together, you have to check accuracy. You have to make sure. It's mentioned already in your manual. And this one. Check accuracy at every step. So maybe lumping will affect your data. But if you do lumping properly, then a slight tuning is of course needed. You need to retune your equation of state again. And if you make this complicated, you might find yourself that you are repeating the tuning from step 0. Because if you do a grouping probably or correctly, then you will need only slight tuning, not severe tuning.
You have to do the grouping before doing the saturation pressure, I mean, at the beginning of our project, or, for example, after the separator.
In the group project, you will only match the saturation pressure and do lumping. But usually we match everything, then we do lumping, then we check accuracy. We compare average absolute error. Because we use lumping or grouping, we use it as also, you can consider it as a tuning process also. Okay. You will change you will control this distribution to improve your results. So in your 10 project, you will start like this. You will have step 1, match. So you will have, you remember that we have steps in our tuning process. So here we match saturation pressure, and here CCE, here DLE, and here separator. And now you have one step in this position. We normally go like this. We match saturation pressure, CCE, DLE, separator, then we lump with keeping all of this matched. But now, to save time for you, we'll make it more simple or simpler or easier. So after matching saturation pressure, you will do lump and you will compare again the saturation pressure. If it's shifted, you will need to match it again, then you go further. And all of this is mentioned already in your third project outline. So you have this, don't worry about this, it's all mentioned. The question is how you will do this. Are you going to do it correctly or not? As we have taken here, or you invent something new? If by the way, if you want to try something new, which is mentioned in PVT books or reference, you are welcome to do this. If you try something new from your mind, you are responsible for yourself. Because maybe that is wrong and in your mind you think that's good. So I will repeat that again. I will copy this to compare, to show you. I will copy the last one and to show you after grouping how will happen to the results. And exactly, you need to do this during those steps. What I would like to see in your report is, I would like to see average absolute error percentage before and after each step, and I would like you to comment on these results. So show this comments and graphs.
What do you mean with comments?
Okay, for example, when at first step, before matching saturation pressure, you'll say, after setting up my equation of state, I found that the initial results were off by 10% or 5%. In next step, I will try to improve this. So you will start step 1, then you say, okay, I got the match by interactive binary coefficient. Then I can start lumping. And you show the results. You show, for example, the first plot where the saturation pressure is already matched.
Yeah.
So you said AA for the average absolute error, we have to do it before and after the matching.
Yeah. You need to do this at each step, before and after. Also with the lumping, and it's already mentioned. Also for lumping. For example, if you match this, and you say, okay, my average absolute error now is 1%, then you do lumping, then you come back again. So imagine that I will refer to average absolute error as x or as a star. So you will do this like this. You will do it before and after each step. You calculate it here, you say, okay, it's off, I want to get the match. Then you see how you know you got the match or not. You will calculate it again, and you will write some comments. Then you do lumping. Then you say, okay, lumping made my results worse or better. Then I will see, do I need to go to this, or I will match again this and continue from here, and I will calculate average absolute error again and go here and so on. This is how you evaluation. Before you try anything, you evaluate your data, evaluate your step. So
that means I will match it everything again and again.
Yeah.
So that I get better results.
Something important. I noticed that okay, average absolute error before and after each step. But for what? For what I do average absolute error? If you are going to match this, then you show the average absolute error for PSAT. But here you will need to show the average absolute error for PSAT with CCE. And here you add plus DLE. And here plus separator. You add this to the first value.
But from after the first lumping, I will get the CCE. If our average absolute error is greater than 5%.
For what? For what?
CCE.
For CCE.
Yeah. If it's
you will match again.
Yeah, if you match it and it's greater than 5% from this, you try to match it and greater than 5%. Do you still need to go?
You cannot.
You just go back again.
You need to loop here until you get a good match. Then you go here. And I have already shown you this before. Maybe we have Now I can just make that simple for you. Here I'm talking about here you need to calculate the average absolute error for all of your experiments here. For example, if we are talking in this step, you will need to do the average absolute error for PSAT only. If you are in this step, you need to show the average absolute error for PSAT and CCE. If you are in this step, you need to show average absolute error for 3 of them and for 4 of them in this step. However, our lumping step is here. So you will start like this. You will enter your composition and you do the steps, build the equation of state model. Once you have an equation of state model, before matching this, calculate average absolute error. You'll say, okay, I have 5% error. You will do tuning and you will say, okay, I improve this to 1%. Then you go to lumping. So you have 1%, you go to lumping, you come back again. Average absolute error, you say, okay, 5%. If your PSAT is large like this, you may, after lumping, match PSAT again, then you go to CCE. And you calculate average absolute error for PSAT and CCE again before this step. You do matching, then you do that again after this step, and so on at each step. This is necessary to follow your results, to follow your improvement, and so on.
Maybe we say that we have 5%, for example, then we again match it, then it is, for example, 1%, but we have the 1%.
Yeah, with grouping. Yeah, this is that's why I said you go back, match this, and you go back here. At this step, your composition is already lumped. So it's not like before. Before we go without lumping. Now you do lumping step in between. Now I will copy this composition. I copy this model and I call it group. And now I will group different components together and I will compare that with the model without grouping. Because we are asked to keep the results. So let's do this here. Grouping, manual. Okay, I will group into with C what? CO2 with C2. The rule of thumb here is about the molecular weight. Your general idea can be like this. I collect the components which have the same molecular weight. Not the same, but near to each other. Once we have components that have molecular weight which is similar, we can group them or lump them in one component. So this is what we have done in this step, So now I will just lump or group from, okay, I can do it in different ways. I can take all of this as one group and I keep those. I will do this. So now I have grouped N2 with C1, CO2 with C2, from C3 to C6 together as one component. Then I keep the pseudo components without change. So now I press OK, and you will see now. In this way, we could lump the components without changing the phase plot, because you see now. Before I just tried something a bit, and the phase envelope shifted without any basis. But now I use the rule of thumbs that is already mentioned in PVT box in grouping. So based on that, I found that I could lump my components to 6 with keeping the first envelope with the same shape. So I can also, in this step, for this composition, I can also compare, for example, BSAT. So it was 2,620 and now it's 618. So it's okay compared to lab data. I can also compare CCE and you found that from here I could group the model with keep the CCE matched. I can comment on the graphs, however, the average absolute error needs to be calculated. You need to calculate that to show exactly what you have done here in terms of numbers. I will go to DLE. And you see now for GR is a little bit shifted. So now we have this shifted. You will need to improve this. If your average absolute error now is more than 5%, then this is not acceptable. However, in Germany, in general, this GOR, you know from the graph, it's not okay. When you calculate average absolute error, it will be more than 5%. So that's not acceptable. You will need to repeat matching. So now your choice. Do I need to go back with grouping? Again, you will try different choices. If this choice is the best one, then you will need to do matching again. And matching again, it means you use pseudo-components. If you group. Okay, let's show the other results. Okay, for oil formation factor, it's still matching. If we go out from here and go back to it seems that the grouping was not accepted. We said okay. I forgot to press exit and save. I just go out without saving the group. So I will need to repeat. showing the results again. So this is the grouped model, and you can check that from here. Now you have 6 components or 6 groups, and when you evaluate this, okay, it's still the same. So even after grouping, the results were good. So that's it. There is nothing new. You will just have to do this step in your project here, exactly between step 1 and 2. And I will offer you general advices. If you have any problem, you can send me an email, then I can reply. But general problems, not how I can match match the results in my term project for viscosity and so on. Not specific questions, general questions. Otherwise, I will send you the solution and you.
What are general questions?
Yeah, you can ask just general questions, and I can support you with advices and so on. However, the objective here is to make everyone able to achieve the full mark. The full mark. Yeah, this is what I want to see from you. But you want also to work to achieve this. I wish to have all of you have full marks. This is what I wish, but you have to work. Is there any questions?
Could you send us the solution?
That's it for today.